So the current divider is for parallel resistors, which is where resistors and other elements share a single node pair or two nodes, and it's based upon Kirchhoff's current law. So here we have a circuit with a current source IS in parallel with three resistors R1, R2, and R3. So the current through R1 would be the parallel combination of R1, R2, and R3 divided by R1 times the current source. The current through R2 would be the parallel combination of R1, R2, and R3 divided by R2 times the current source. And the current through R3 would be the parallel combination R1, R2, and R3 divided by R3 times the current source. So now let's see what this looks like on a circuit with numbers. I have a 10 milliamp current source in parallel with a 12 ohm, 6 ohm, and 4 ohm resistor. Let's find the current through each of the resistors. The current through the 12 ohm resistor is 12 in parallel with 6 in parallel with 4 divided by 12 times 10 milliamps, which is 20 over 12 milliamps. The current through the 6 ohm resistor is 12 in parallel with 6 in parallel with 4 divided by 6 times 10 milliamps, or 20 over 6 milliamps. Now notice something interesting. The current arrow is pointing up through the 4 ohm resistor. That means that resistor does not obey the passive sign convention. So I put a minus sign in front of this one. Negative 12 in parallel with 6 in parallel with 4 divided by 4 times 10 milliamps is negative 20 over 4 milliamps, or negative 5 milliamps. So it still needs to abide by KCL. So when I write the KCL equation, I'm going to get that 10 milliamps equals 20 over 12 milliamps plus 20 over 6 milliamps plus 20 over 4 milliamps. And what you'll see is that this does add up to 10 milliamps, so it obeys KCL.